Okay, welcome back, students, for lesson number one, part number three, and this will be the last part for lesson number one. Okay, so let's continue here with the idea of graphing. But in this case, we're going to be using the slope and y-intercept form. So basically, I need to first define what is a slope. You've learned this, you started learning this from grade 9. You started with the idea of direct variation and partial variation. But now we're going to be generalizing it into the idea of a slope. So I believe by now, if you do not know what's a direct variation and partial variation, it's basically when you have a Cartesian plane, a direct variation passes through the origin, uh, passes through the origin 0, 0. That's a direct variation. So here's the y-axis, here's the x-axis, and so we call this a direct variation. This is what you learned from grade 9. I mean, I'm speaking to anterior students, I'm assuming, but if you're watching this, it's also a good skill to have. It's okay. So this is a partial variation. A line that is passing, that is not passing through the origin is a partial variation. But now you are in grade 10, you've gone far in grade 9, so you get to start talking about slopes. So this idea of a slope, what is a slope? Mathematically speaking, okay, I'll just say it this way. You can define slope however you want, but you must follow the equation. So mathematically speaking, we define, or rather, I can say a slope is defined by y equal mx plus b. The b here, well, first I'll tell you what is m, because m is the main deal, it's big deal here. But I'll tell you what each of these are. I already mentioned from lesson parts 2 of this lesson that x is the independent variable, y is the dependent variable. So I will just talk about only m and b. So where m is the slope, and your b here is there. So I like to put a quotation mark on it so that you know the b I'm talking about. Where b is the y-intercept. So just like I always say, picture speaks louder than words. I don't know if somebody else has said that, used that quote before, but I like pictures. It helps my students understand very fast and save me the stress of explaining the thing for too long. So basically, this intercept right here is your B. This is the B I'm talking about. The slope is basically this M here is how steep the line is. The graph is basically. So the line itself is the slope, how steep it is. If it's standing straight, it means that there's no slope. If it's flat, there's no slope, obviously. But I want you to mention that the B here is this y-intercept. So call that B the y-intercept. So that is this dot here. So, but this M itself, the M is rise over run. We use this when we are given an equation. Whenever equation is given equation or a graph. Uh, equation or a graph. So your M in this case is going to be, well, okay, now you know what M and B are. Now let's take an example so we can see how this works. I'll take part B in this case. And part D in this case as an example. So I've already explained what a slope is now, right? So let me get a graphing paper because we are going to need a graph to do this problem. So you know how a slope is defined, right? It's defined by this. Now we're going to use that and compare the given equation with the slope y equal mx plus b. Once you compare, you can see without any doubt that your m is -2 and your b is 3. So your m in this case is -2, which is equal to your rise over run. So this means that your run is 1 and your b in this case is 3 without any doubts. It's very convenient and clear. Whenever you compare something like this, you know what a form is. When you compare any equation you're trying to solve with the original form, you can find the coefficient you're looking for very easily in this format. So your b, which is the y-intercept, is 3, and your m, which is the slope, is -2 over 1. So this is your slope, all right? Your m is what we denote as the slope. I hope it's clear up to this point. So next, you just have to just do your Cartesian plane and graph it, and you're finished. So I'll do 2 examples on this just to make sure this is clear. If I have to do a part 4, just to ensure that I keep the standard, I need to do 15 minutes per lesson. I mean, 15 minutes per video, just to ensure that you guys are not bored, one step at a time, one skill at a time, and like that, and to build up and understand what's going on. So basically, to graph this, we need to start with the y-intercept, which is a 3. So 1, 2, 3. Here is the y-intercept. And now our slope, remember our slope is m is equal to -2 over 1, which is rise over run. What this means is that your rise is equal to -2, and your run is 1. So rising down by -2, 1, 2. Actually, let me use a different color. 1, 2. And then running 1, 1, no, just 1, 1, and make a dot. And again, repeat the same process. 1, 2, and then run 1, 1, and make a dot. And three dots is enough. You don't have to go crazy about it. And then you connect it. And just remember that a line is continuous. So we put an arrow to indicate that this line goes forever. So it's a continuous line. So we'll go ahead and label this as a graph of y equal -2 x plus 3. Now, one more example here. I have done negative. Now I need to discuss the case where you have a positive, just to make sure I touched upon all of this, because I need to address some questions where we have to do different examples, just to make sure that you know exactly what's going on now. So another example is when you have a case like this, a positive slope. Oh, you draw here, we'll call this a negative slope because it's decreasing, right? So this is so-called a negative slope. This particular one here is a negative slope. So let me do an example with a positive slope. All right. So basically, just as usual, we compare. Comparison is very nice. It works really well in math and physics. So whenever you're doing math, any science at all, if you know the original form, you can compare what you're trying to work with. You can find the missing something you're looking for. So compare with y is equal to mx plus b. When you compare, and we know that whenever I have an x, the coefficient of that x is simply a 1. So when you compare, you can see that your m is 1 and your b is 2. So this means that your m is simply a 1 and your b is a -2. So 1 divided by 1 is still 1. So this is your rise over run. So feel free to pause the video and try to finish it before I do. This is nice to actually try to finish the problem before I even do it, so that we can compare with what I'm doing. It's recommended to have an actual graph, to have a nice diagram that you'll be pleased with your solution or with what you've done. So try your best to pause the video and try it out yourself before I finish it off. Okay, so we are here. Here's a y and here's an x. Your y-intercept, which is your b, is right here, -2, 1, 2. Right here is a -2. So from this -2, we are rising up by 1 and running 1. So, so go up by 1 and then run 1, 1. And go up by 1 again, go up by 1 and then run 1, 1. The reason why I'm using all these different colors is for you to see how to go one step up or one step down, because this is where it's going to get confused. Please do your best, okay? To see clearly how you count, go up by 1 or go down by 2, whatever the case may be. All right, so just go ahead and connect these dots. So this is your graph of y equal x minus 2. All right, so that will be all for this particular concept of graphing a line using comparing using your y equal ms plus b form, and then using your rise over run, you can graph it very quickly. And then for the next lesson, we're going to graph equation of two lines, or graphing each pair of lines and finding the coordinate of point of intersection. So basically, you're going to be repeating what I've done here, but in this case, we are doing it for two different equations and then finding the intersection point. So it is completely necessary for you to have your graphing paper ready. It's very important that you have an actual graphing paper ready for the next video, which will be about finding point of intersection of two given equations. So this is going to be about, it's going to be lesson number 1, part number 4. So thank you for completing part number 3. So part number 4 is going to be very interesting, as you can see already here. So feel free to leave a comment if you feel like you want me to do a few more examples on something like this, or maybe using something more complicated, or with a fraction, whatever the case may be. Hopefully I'll get to something with a fraction in this video on this class, but it doesn't matter. But the idea is always the same. Whether fraction or not, it doesn't matter. As long as you can identify your y-intercept and starting from the y-intercept and counting your rise over run. So, and yeah, so let me not take too much time on this, because it's supposed to be a 15-minute video. I will see you guys on the next class. If possible, I'll do a quick review and then before I begin. All right, so that will be all for today, and see you in the next video. Bye now.